While the current voting system functions, there is much room for improvement. For example, all states currently use a different validation system. While some states have good validation systems, some have poor validation systems. In 2018, Florida was attempting to match signatures in order to verify voters. This type of poor validation opens the door for all sorts of voter fraud. Voter fraud is harmful for two reasons. One, voter fraud delegitimizes the election. And two, creates the need for a recount, which costs taxpayers money. Our solution is to implement a blockchain validation system to the current U.S. voting system in Florida. What is blockchain? Blockchain is a digital public ledger that validates transactions autonomously. One key component of blockchain is that it is always validating transactions with previous transactions, thus to keep a record that all transactions are valid. This is an important aspect of blockchain and will be important in its application in voting. In order to fully understand how blockchain can be applied to the U.S. voting system, we first have to understand how blockchain works. There are three primary components of blockchain, the first being private key cryptography. This means that each individual person has a private key associated with their account, which gives them access to the values of their account. Each key, or ID, can be described as a fingerprint that determines the identity of the block. The second key component of blockchain is a distributed network that shares a ledger. This means that there is no central node within the network and that all nodes have the ability to talk to each other. When they talk to each other, they are verifying the values within each node and comparing them with the values within the private nodes. This means that every time a transaction takes place, all values within transactions are checked to make sure that they are consistent with the values that are being updated. Here we have a visual representation of blockchain. Each block has the hash code of the previous block, thus working in sequence. But what happens if somebody attempts to tamper with the code of a block in the middle? Since the hash code of the previous block is stored in the next block, it is checked. And since it recognizes it's not right, it will not accept the changes. This is what makes blockchain so secure. The fact that if you change a block in the middle of the chain, you have to change the values of all the blocks following it, making it very difficult to hack. While there are centralized transactions, each transaction is distributed to everyone within the blockchain. This means that each person has a copy of the transaction history, although it is encrypted and you cannot tell who is paying who or who is voting for who. Now, when a new block is added, it is added to everyone's chain. And then, through this decentralized network, they all verify that the block has not been tampered with and matches. Once they have verified that, it is added to the chain and confirmed.
So, who is the target demographic for this proposal? We're focusing on Florida for two main reasons. First, they've already made efforts to fight against voter fraud, which the blockchain will help with. And second, they know the logistical pains of election recounts.
According to an article on ABC, at least 8 million Florida ballots were recounted 3 times, with an estimate of total cost being $10 million. Hopefully by now you understand how blockchain works with Bitcoin, but how exactly can this technology be implemented to the U.S. voting system? First, we must decide upon a blockchain database to choose from. In our research, we found that the Ethereum blockchain platform is the most developed and secure platform. The main benefit of the Ethereum blockchain is that in addition to storing values and keys, it also updates the latest terms of a smart contract. Secondly, to initialize the blockchain. In order to initialize the blockchain, the first block must be built with the characteristics for the whole chain. Then, the characteristics are applied to the entire chain and the smart contract is agreed upon and implemented.
So you're probably wondering what a smart contract is and why it makes blockchain so secure. Well, it's just like any other legal contract, except once the terms are agreed upon, they are written into the blockchain's code. Once the blockchain is started, it then self-executes the protocols of the contract. And the most important part of the blockchain security is that once it is started, it blocks all external tampering until the contract's duration is over.
In order to fully implement blockchain technology into Florida's voting system, we must first distribute private voter keys to registered voters. This phase will be implemented similarly to voter registration. We believe that ID cards containing the encrypted key is the best way to ensure that voters have easy access to their ID and do not forget their key. The second phase requires balances to be created for each voter. The balance per election will depend on the maximum number of legal votes one can cast on a ballot. The third phase of our implementation is to create public keys for candidates to receive votes. This will work fairly similarly to in Bitcoin, where transactions will occur between voter and candidate, with currency being votes. This is secure because the votes build off one another and are constantly being checked. If a vote is requested that is being tampered with, the chain will deny the change and continue to count legal votes. Candidate totals can be compared at the end of election in conjunction with extra data regarding voting totals.
Our plan for this project involves three main phases: developing the blockchain, which requires hiring a highly skilled software developer, assigning and distributing voter IDs and secure voter keys, and security improvements once the blockchain is up and running. Developing the blockchain will take approximately 1 to 2 months, depending on the complexity of the smart contract. Modifications to the blockchain will be made once the software has all of the required functionality. Assigning IDs and voter keys to registered Florida voters will take a substantial amount of time and resources, but will allow for voting convenience in the future, as well as reducing the number of reasons for a recount, which costs millions of taxpayer dollars every year. An electronic voting system is sure to be the target of digital attacks, so the quarterly software analysis and improvements will act as a barrier and ensure the long-term security of the system. It shouldn't take longer than 6 months to get the basic infrastructure set up and ready for increased volume. After that, the most important part will be maintaining the blockchain security. The proposed budget for this project is $130,000 with an additional $20,000 per year for future software maintenance. I'll break down the cost further. Creating a secure blockchain system requires a highly skilled software developer, hence the steep cost for this phase. We consider this a worthwhile expense because the blockchain will act as the backbone for the voting system. Assigning and distributing new secure voter IDs will be a challenging task, but it will be a minor change compared to Florida's current system. A majority of the funding for this phase will go toward manufacturing the physical identification cards and the labor required to distribute these to registered voters. As we previously mentioned, the quarterly software improvements are necessary costs because the system will rely on having up-to-date security protocols. We've budgeted for 4 weeks worth of software analysis and security updates from our software developer, which will be split into 1 week's worth of work every 4 months. This part of the budget is the most flexible because the resources devoted to software security will be based on the threat assessment for cyber attacks.
We anticipate that the benefits of applying blockchain to the Florida voting system will be restoring trust in the voting system, increase transparency on election results, and reduce the need of a recount.